So now officially welcome everyone. I'm Gustavo Conte. Me and my colleague June Kim will be hosting this webinar. I really appreciate you all joining for this. I've set some, let's say, some rules or some recommendations. If you have any questions along this webinar, please put it in the Q&A or in the chat. The Q&A assures that we look at all the questions and we will address all of them to our better knowledge at the end of the presentation, or if in the middle, if it's let's say it's the right moment to do it. So I'm based in Brazil. I work at pre-sales for SecurityGen. And John, please introduce yourself.
Okay, thanks, Gustav. Hello, everyone. It's nice to have you here today. I'm Jun. I'm from Korea. I'm working in SecurityGen as a pre-sales and the managing director in Korea. So together with Gustav, we will have a session about 5G security topic today. So please enjoy it. So over to you, Gustav.
Thanks, John. So the idea here is to talk a little about the ecosystem. It's quite large, if you can see. We are, let's say, we split in 3 pillars about enablers and users. So we have a cloud-based technology. So also ETSI and IETF has some to say. Cloud native has a lot to say about it. And there are chipsets makers like Qualcomm, etc. So there's a lot of parts of this ecosystem that are broader than 5G, but are, let's say, mandatory for us to enable this technology. For sure, we have the core players, which are the operators, which is GSMA, their association, 3GPP, which built the norm, say what is 5G, which are the standards, and we'll get a little deep on the standards in a further notice. So have the vendors, core vendors, RAN vendors, now open RAN vendors, and you see you have also the authorities. So you have a lot of good contributions on public agencies, governmental institutions that help us on improving 5G, normalizing 5G. So you see there's a lot of information. It's a lot really of partners on these and because of 5G relevance. So John, how do you see it? How can we explain this in a better way?
I see pretty much same as yours, Gustav. So if you are in a security posture, most likely you start from 3GPP, and maybe you start from many security specifications such as 5G standard TS 33.501, which is main 5G security specifications. And you can refer to many considerations in ENISA as they keep releasing the cybersecurity report over the telecom industry. Then our vision over all these materials, because one of our main work is collecting those materials and analyze them to provide a more complete visions. Of course, you can follow all those materials, but it takes some time for anyone who goes through all of this. So this one is about the 5G is not just only business for operator, but also it is considered as critical infrastructure. The CISA, the Cybersecurity and Infrastructure Security Agency, who is U.S. government branch, is focusing on improving cybersecurity over the nation's critical infrastructure, which includes telecom and utility, public health, and logistics. And they also mentioned that ICT is integral for the daily operation and functionality of U.S. critical infrastructure. So as I said, telecom is not only business, but also enabler. So that's why the CISA break it down into 4 main pillars of it. So just to add, CISA also stated that if vulnerabilities in ICT supply chain, such as composed hardware, software, and managed service from third-party vendors, suppliers, and service provider, and contractor, if they are exploited, then consequence can affect all users of that technologies and service. So they underline again the importance of security of telecom as both critical infrastructure and service provider. In the next slide, Gustav will explain how focus has been changed across the generation in terms of security. So over to you, Gustav.
Thanks, John. So I have been on this business for quite some time. So I have seen from 2G until today. So on 2G, you have mostly turnkey projects. You have a small set of vendors like Alcatel, Ericsson, Nokia, and they build everything. So operator was responsible for physical infrastructure, the buildings, and everything else, the software, the equipment, computing capability, it was like usually proprietary hardware. So all the solution was verticalized, and solution security was the security available at the time. So the vendor built it and said, okay, I built it in a safe way, so it's safe. I integrated myself. So it's I used let's say the best practices. When you move to 3G, you start needing start competition, and you start moving access out of your main vendor, and you need to move integration. You now have two vendors doing integration into the network, and usually you get your billing out of this. Sometimes, right? You can keep it or not, but what you have seen is that more and more of these, let's say, specialized functions move away from the single vendor you get on 2G. So when you are on 4G, you already have computing being used as regular computing off-the-shelf hardware. So you don't need to buy computing anymore for your core vendor, but you still have solution security on them. By the late 4G, you start seeing that only doing security by design is not enough. You need to implement security tools. Sometimes you implement some managed security services to support you. But the operator is now responsible not only for physical infrastructure, but for the integration, because networks became unique, right? You address these on the coming slides, but no network is let's say, is the same or very similar to the competition. Depends mostly on the decisions that have been taken, let's say, from 20 years to now. So how your network ends up is a unique network. And sometimes even the physical infrastructure is not yours anymore. You're building it over shared sites or using hyperscalers, you put in on public cloud, etc. So this change in balance is something that's clear for me. And when you just have to manage security posture, it's not only about stating a posture. It requires some change on the organization. Right? It's not feasible in the way we started as a 2G organization. So if you take a deep look on the organization, thanks, John, what you see is that you have all these silos on the company, and ideally you should have one area that is transversal to avoid that, let's say, being a network or an IT initiative. Let's put it that way. So I've been working over 10 years on operators, straight on operators, and then being a network guy. So I understand that there are already some friction between those two areas because they are the main technical areas of the company. So no one would, let's say, not about respect, but would accept too much if one of those was responsible for the cybersecurity. So the idea is to have an independent area, also because if you are responsible, for instance, for doing the transport rollout and security in a mobile operator, I'm sure you do a very good transport rollout because this is the main business, it's your main focus. So when security is not your main focus, you can do, let's say, lots of good things, but you cannot assure this is enough, right? So that being said, I think we should ask our audience about what you see. So if you see this structure, what do you think? So Maxim, please, thank you so much. If you could help us on this, because these polls, I like those because they guide us on how to present. Okay, the polls are always anonymous, so you can just put it here. I'm just talking about percentage. So if if we could have some answers on that, just get some vision. Okay, you have some answers already. Give me more time if someone else is wants to contribute. Okay.
Thanks for everyone participating in this pool.
So thank you all. I think we could, yes, thanks. So what I see is that, okay, this is not the best structure, right? Or not the structure that you have. So if you want to send it in Q&A or to the chat, what could be improved, that's good. So we could, let's say, work on it by the end of the presentation. Right? Maybe I have the wrong idea about it. So thanks for the poll, and then we understand that this is part of the deal, right? To have an area or have people accountable for security, but also this is not enough, right, John?
You're right, Gustav. So let me take it from here. This slide is about the topic that we are dealing with myriads of network scenarios. To think about 5G, 5G is not a single network scenario thing. So first, there can be wholesale who is selling the access. I mean, the new generation radio access to other operators. And there are many different models when they sell to operators, depending on which part to be included or which part is not included. So here we have the variations already. And we have several MVNOs using this, and some has only UPF. Some may have several more like their own UDM, maybe some core function inside it. So MVNO deployment models are all different. And we have a private and public cloud. So responsibilities and definition of borders are depending on the telco cloud site types and architecture shapes. So again, we can say that there are so many variations in the network scenario. There's no network having same loop. Maybe those inside of the one group, maybe they look alike. Other than that, there's no MNOs having same loop. So which means it's very hard to define the borders and responsibilities, as there are many different combinations of infrastructure, business model, and service model, etc. So how can you define the exact border when it comes like wholesale sell their access to an MNO? And MVNO leads this infrastructure. So we have to say very expanded term for the border here. In this slide, maybe we can have a moment for the discussing when might be a perfect time for security network for 5G. The answer is quite obvious now, or maybe already late. The security network is part of the vertical integration. So planning for security deployment has to be done in parallel with the horizontal planning. In other words, as the network node being deployed, so must their security integrations. And it should be done on level like a node, domain, and end-to-end and service use cases. I know that these approaches are already well known and already documented, even in previous generations. However, end-to-end planning and deployment and testing have never been as important as it is now in 5G, because the advent of IoT devices that are expected to float on network in billions will pose unprecedented challenges. And addressing this challenge after the network has been deployed, after soft launch, will dramatically raise the cost and risk. So please don't wait. Now is time, or maybe already late. Again, here the cost of prevention and remediation now before service launch is much less than the cost after the service launch. The failure, fix, change after service launch is unacceptable. And let's have a quick technical moment here. I like to take on example how attacker get into your core network from outside. So people think the core network is completely closed, but there is always ways. And here I pick one of the cases. So typical procedure of the case I like to introduce is like this. The attacker, is trying to find the fingerprinting in the range of target public address associated with the 5G core network, and trying to discover many exposed hosts with open services, and exploiting the web vulnerabilities among open services, and then taking 5G core network access and to access the network functions. Then maybe conduct some abuse like deploying the fake node in NRF. It's like this. So you have an attacker here, and this guy wants to access to inside the core network. So he's going through the data network and all the way to the UPF, because UPF is one of the functions handling the traffic for data network. So again, please don't get me wrong. This is one of the case. There can be a lot more other ways. Anyways, so this guy took a public IP address and reverse it for other range that would be part of the infrastructure. So the guy figured out that one range here. So he tried to find it, scan it, and found one of interesting things. Looks like the core network things. So he continues scanning. As you can see here, he used the mmap here and try to reach and find it and open service, as I said. And luckily, he could find one web GUI console, which is for their core network management functions. So using various web vulnerabilities like a path traverser and cross-site scripting and SQL injection, he tried further and tried to get such information like the subscriber informations and security, which is very crucial, and operators configuration, environment information. So this one, he actually used path traverser attack and was able to get these pages and got the information about the operators. And here he got the information of subscriber. And again, he got the information of operators configurations. And this guy continued scanning and found the access possibility to one of the network function. So he decided to conduct network function abuse. So as I said, he tried to scan and discover network function using several scripts. I want to show one of them here, and decide to delete network function out of the NRF to interrupt the service and traffic. And he was able to do it. And then he decided to actually create his own network function, which is fake network function, which was successful, as you can see the screen. So this one is for hijacking and typical denial of service, and many something like man-in-the-middle attack things. So this is one of the example I like to share. So your core network is not safe. The risk having the NRF interface exposed to the attacker and without the proper authentication can have terrible consequence. Indeed, each function is responsible for a task, and hijacking this function would allow attacker to be persistent and still secret and monitor communication and pivot to sensitive slides quickly to gain access to other infrastructure. So now let's talk about the best practice from Gustav. So over to you, Gustav.
June. So as June has demonstrated, you have very much improvements on service. So signaling has been converted to HTTP2. And I also comment that you could start discovering with a web browser and try to get information just by HTTP GET. And you don't need let's say, a set of a new stack, as we used to do in legacy signaling tests and etc. So it's much more straightforward. So functionally, that's very good. The point is, when we improve the functionality, sometimes we improve facilities to the attacker. So you can now subscribe to information on these APIs. You can just say, I want this location information, or I want these records to be sent to me from a specific customer. And you just sit there and you have not even do an inquiry, because the network will actively send you this information. So what 3GPP has done is not to think about only functionality. This is the base definition, but a set of documents called SCAS, Security Assurance Specifications. It's divided in two sections. One section about each network function, typically. So for AMF, they will talk now about how to allocate 5G GUTI, because it's sure it should be there. You know how to, what to do, etc. That's the base specification, but how to do it safely is on this additional set. So when you do internet mobility, when you exchange keys, etc., all these will be described. Same for NRF, for UDM, how do you do the deconcealment? Because one thing is about do it functionally, other thing is about really implementing it the safe way. So associated with these, let's say, specific network function documents, you also have some very specific documents, with very generic documents, which is 33117. It's a practical guide of that any standard, any security standard would bring for general solution baseline. So for any machine and for any function, you should take care of data protection. You should take care of logging, ensure logging is in place, accessing to operation accounts, operation maintenance accounts. And if you use a base, let's say, as everyone else use a known web server engine, you should make sure all the, let's say, unnecessary features are closed. But there are other relevant documents on security, not only SCAS. So all the TS33 series includes recommendations for the 5G technology, so the base technology. So we have specific for assurance, you have specific for AKMA, for key management, and even some detailing when I working on applications for vehicle to everything. So this is very drill down that has been done, because securing ultra low latency communication is not the same of securing, let's say, a data center, right? Not everything applies, and it's not that about, let's say, availability is the main asset you're trying to protect here, not only confidentiality. Sometimes you need to be aware of it. And for sure, they still deal with the security impacts of virtualization. So think about it. It's like from the first slide, you need to understand virtualization, and then you need to understand the functions and how you connect those. So if you look at this and add to it all other studies that have been published by us and other researchers, right? We must consider this third-party research as well. So if I can take two enhancements that could make a difference on the core security, I would go for SEPP, right? Which is really a function built to be a non-transparent proxy, so to hide your internal topology, to provide multiple authentication, integrity, point by point. So in theory, this would mean that you can assure where did you get the signaling from when you're dealing with roaming interconnection. So it should ensure the originator MNO. It should ensure that for every step, so if you're connected through several hubs, several IPX providers, it should be signed and it should, let's say, be assured for integrity at each step. This would be really very good. I'm not sure how much of it will be commercially implemented. So we started talking business. then tech, and now it's somehow business again, because this must be scalable. So currently at 3G, 4G roaming, I understand that, let's say, the average operator receives 1,000 updates per month to evaluate and see if it must be applied. They must be applied on the network to ensure that roaming keeps working. It's not that we're increasing roaming, doing anything better. It's just regular maintenance, because every time one operator opens a new node, new ranges, etc., it has to inform it using internal formats, formularies from let's see, IR18, IR21, IR82. So in that matter, if you think that you also have to do that for encryption, from between each of your roaming partners, this may add some complexity. So from this year, we start seeing some IPX proposals for commercial 5G roaming, not only inside the an operator group, or between, let's say, very attached operators, operators with too much interest of traffic. So maybe we'll finally understand how much of this will be applied. Also, we can finally encrypt signaling. We finally use TLS and make sure that no one can listen to it, or let's say introduce itself to it. And we have a very important function of authentication, and using the, let's say, one of the top authentication methods. Again, this is the good news. When I look at IP-UPS down here on the data plane, it's still GTPU with all the issues that are known to GTPU from 3G to 4G. So this is a vulnerable protocol that must be protected. For instance, you must prevent known methods that like TCP replace or anything like that, that should be successfully inserted on your UPF software. So the recommended way sometimes is not putting another function here, but really increasing the critical part on the UPF. Nevertheless, the final results must be assessed, no matter how you protect it. So those are the enhancements that we could see. So if I take a look, let's say on a more higher side, is that you don't have transparent data, you don't have IMSIs anymore flying on the radio interface, or SUPIs in that matter. You can encrypt backhaul links, but that was already available in 4G and maybe is not being adopted so much. You can do finally some network slicing, and you can, okay, we have a poll here. You can do some network slicing, and you can ensure confidentiality. You can do lots of things. And also, you're able to encrypt signaling as a command, right? So, John, what about this? Have you seen these MNOs implementing the security enhancements or not?
Well, Gustav, frankly speaking, not really, especially on signaling encryption. I would say almost all MNOs are not doing this. Maybe I'm wrong, so maybe we can ask the audience if they have seen any from their side of the world. So what do you think, Gustav?
Yes, good. I've seen the poll is out. I've seen people is already helping us with that. Thank you so much for everyone contributing. Again, this is an anonymous poll, so it's no matter we're talking about your company. It's really an overview of the market. We can think to help everyone on this call, not only us, to better understand it. So we give it another 10 seconds and we get to the poll results. But this time, differently from the previous one, this time I think we guessed it right, or we are aligned to understanding of the audience, right?
Yes, I'm happy. So, I'm not wrong.
Yes, it's good. Everyone likes that. So I'll be just ending the poll right now and showing how we have it on this audience. Thanks so much for everyone contributing to it.
But so, look, Gustav, I said one yes in the poll, the second poll. So I'd like to hear from, we may have chance. So.
It's good, yes. So why not 20% of our audience say they have already implemented signal encryption, 80% not, but half of it is in turn is going to implement. That's also good, right? So we have like 60% of audience saying that they understand the importance and they will implement, already implemented or implement anytime soon. And I appreciate that. And if you're not implementing it anytime soon, maybe you're not implementing it at all, because you must consider that encrypting a core that is too much connected, right? Let's say you encrypt NRF, then you have to encrypt the full network overnight or on the same maintenance window. So sometimes it just won't be that easy or that feasible if you take too much time deciding. So maybe if you're not doing it anytime soon, you're not doing it. So, John, I think we could take a look at the impacts of doing or not doing that.
Yeah, okay. So, yeah, so as I said, in real life, no one has encrypted, but I can say no one because I see the one. So anyway, not many has encrypted signaling for many regions, such as service quality assurance, maybe for e.g. maintenance or monitoring. And okay, so as for PFCP, it's a good thing separating control and user plane, especially when we think about low latency applications. However, the PFCP itself is not safe protocol. So you need to be sure that this PFCP environment should not open to any unauthorized access. And authentication network function, it is quite a really important one. So NNF and SCP should verify all requests, such as registering NF instance, deleting NF instance. Otherwise, unauthorized requests could cause service disruptions, hijacking traffic in core network. I've seen some operators whose NRF is not verifying the request. So we were able to easily register fake network function into NRF. And in addition, other network functions are not even looking at this NRF. So instead, they are just looking at their local configurations. So this is totally against 3GPP specification. So when we are saying the 5G core is service-based architecture, which is quite dynamic, not static, but having this local configuration is make it like a static. So that's why it is totally against 3GPP specification. And since everything in telco is trust-based, so if you don't encrypt, isolate, and don't control authentication, a log network function may impact entire network availabilities. And finally, I really want to say the 5G core is all about API. As you know, the main interface of 5G core is API transaction over HTTP2. So, which means you should control API, protecting your network from maybe malicious API requests. So let me pick one example. Attacker may send API with a wrong syntax on purpose, like missing brackets on purpose, expecting some kind of crash in API parser in the endpoint of node. So something like API gateway with inspecting feature for all incoming API might be on one of the options here. So we just set the reality even after the security enhancement. So Gustav, should we simply just fire it?
The answer is always not the one they were expecting. It says yes and no. I would like very much if we could say yes to this. Yes, just put a golden box and solve everything. That's the answer the network directors want us to give them as well. But if in any terms, you should consider what you have, what's your topology, how you're integrated to networks, which applications, which players have access to it. So those are the expected attack vectors, right? So if you look deep into it, sometimes in the case you have a firewall, but some research indicates that the best way of solving the vulnerabilities is to do a hardening on the network functions, not a hardening, let's say, cybersecurity standard hardening, the one that has on 33117 document. This is just the baseline. So it's a hardening on how it works, how to deal with a malformed packet, as you mentioned before, or with TCP replay attacks and this kind of things. When after you implement this, or if you have your vendor saying that they have implemented this, only way of making sure is to do the test, right? To do the pen test and assure this is happening, this is in place. So finding these new borders or these new attack vectors is really the new game.
Okay. Thanks, Gustav. So I got the idea. Thanks. Well, so far we have covered 5G topic, and I believe there is more. But what about IMS? We still use IMS even in 5G. So what is your view, Gustav?
IMS is rather old. Speaking of technology, for sure, is being straight inherited from 4G to 5G. So it's a solution that's been used for years, but in the scenario of only on the home network scenario. So when you are abroad and you do international roaming, usually operators have chosen to fall back you to 3G or 2G to make the phone calls or to receive the phone calls. But recent developments, which is the cutoff of 2G and 3G in the US, right before summer, so right before people, just after pandemics like that, it's a cutoff of all the 2G and 3G just after a pandemic, and the first time that people have summer and the vacations to go there. So it was a nightmare for operators, as I see, to enable VoLTE and voice over 5G roaming on a short time. So this is, let's say, it's the same of COVID has done for cybersecurity in the world, is the same that this cutoff has done for VoLTE roaming or voice over 5G roaming. So what we have, how this impact me? Well, we have been testing IMS scores and assured that they can be exposed abroad the same way, right? One other thing that maybe passed not clearly to everyone is about flash calls. Flash calls is, I call it shadow telco, because usually the operator doesn't know about it or doesn't receive a dime about it, so they don't care about it. It's not their business. But it's a form of authentication being used by some applications when you just perform a short call to the number and the application intercept the call. So it's a matter of authentication if the application is installed on the expected device, on the end user device, let's say the bank account owner device. Again, if you can tamper with IMS by doing registration hijacking, bypassing authentication, caller ID spoofing, that would be the case, you could just tamper with this kind of flash call authentication. I can just inspect who is calling the expected number and reproduce this caller ID, which is the password they use for authentication in flash calls many times, to another device I have. So vulnerabilities are not only about intercepting, do a man in the middle on the current calls, but also about intercepting second factors of authentication from this kind of flash calls. But again, those are very still standard mobile operator scenarios, and I think we should look at, let's say, more specific ones like private networks.
Okay.
So, thanks, John. If you look at let's say industrial campus like smart factories, smart ports, mines, what they have environment that calls for private 5G networks, right? This is recommended because they have very specific data being stored and cannot be leaked. Usually trade secrets, so they can be done that way. Sometimes for smart ports, you still have some, let's say, public network provided 5G because they're connected to a big city. but that's in that case, we should understand how to implement this in a safe way. So even if you consider this should be isolated network, if you don't follow the good practices we've been preaching before, maybe you're not that safe. And in that case, risks are not acceptable. If we're working over heavy machinery, you can just endanger someone's life by allowing, for instance, that low latency is compromised. So it's not a matter of someone takes over your network. If they just make it not work so fast and lose the characteristics of low latency for 5G, for instance, you can have this truck just going lost and passing up someone or some construction. So as the minimum, as we say, we should inspect what's being implemented and have some monitoring in place. And so, Jonah, can you do a deep dive on the possibilities we have, or what to expect and where we should be deploying detection and protection on these networks?
Sure, Gustav, thanks. So let's talk about private network here. So one, you can see here is standalone, which means the private network has all required function inside. It has RAN, it has 5G core, and whatever required. And at a glance, it may look isolated, well, possibly, but nobody guarantees that attacker cannot play a smart and sophisticated attack against 5G core through 5G RAN or other parameters. So those points should be inspected with all possible test cases. For example, RAN should be inspected, and connection to other core network, maybe some edge node, if there is any, should be inspected as well. So then for those identified points, we are strongly recommend to do some continuous security monitoring, because you need to understand when there comes illegitimate and suspicious traffic is coming to your network, you can take immediate action. So Gustav, did I miss anything here? What else we can have here?
Oh, I can add one thing. I missed nothing, but I can add one thing. Before I add, just we would remind people that but I would like to have some questions or challenges on the Q&A. Otherwise, I'm even being too cryptical or too obvious. So maybe you can add to the discussion so we can address this at the end. What I see in the picture down here is that we have all the virtualization layers. So about hypervisor security and the full virtualization infrastructure security should be also inspected and verified for any flaws. Because in the end, if an application or one attacker is able to assume the control of this virtualization environment, then it's game over. We're talking about nothing here. Okay.
Okay, thanks, Gustav. And this one is private networks sharing public infrastructures. So basically, same thing should be done as the previous cases in isolation case. I mean, but here, as they are sharing the public infrastructure, so it's a bit more complicated. So let's say there's one enterprise company having private network, and which is sharing 5G core from mobile operators. And because this is enterprise company, they have industrial confidential information inside it. I mean, for example, you can think this enterprise as a semiconductor company. So they have a private network to monitor the product line with ultra high resolution cam, which is connected to the application in their core network. And there is a machine learning application, which is analyzing the real-time video stream and detecting any situation of failure or misbehavior. So, which means, just imagine what kind of, the information inside of this video data. Because this is a semiconductor company, maybe they're like a private skill, patent skill, like oxidation process, maybe etching process. So So they really don't want this information going out of their network. So data distribution between the internal one and external one. Please remember, this one is sharing the network, sharing the infrastructure. So the slicing is really matters here. So PNI and NPN, in other words, the public network integrate and non-public network integrate. The distribution between this is really matter and must be controlled. So this is one of the inspection points. So Gustav, what else? Can you please add on here?
Thanks, Jun. Yes, besides having inspection, and it can work both ways, right? Because it can be a matter of the company saying that it's not that they don't trust their operator. They must inspect that traffic to assure this trust is being, let's say, well put. They consider it trusted, but in a world of zero trust is such a buzzword. It's about that. Even if you trust there no harm will come from the operator, maybe someone else is attacking their infrastructure and can go into your site. So not only monitoring, but you can also implement IPS. You can do a structure of protection on the same layer. On the other hand, the operator may have not just one customer for private 5G. They may have a lot of customers. They have 100, 1,000 customers. So some countries like Poland, they define it that to build a private network, you should use the operator infrastructure. So all private networks in this kind of country will be based on the public ones. So think about it. You can trust your customer, but you must monitor and you must defend your shared infrastructure that's shared amongst not only private network customer, but all the mobile users in the end of the day. So it's really some point you should not only inspect, but protect your network to make sure no one is abusing it or there is no malfunction on one of these small cores that could do a storm into your main core. But I think this is really well covered, and we could move on to the wholesale case as well. This is a use case. If someone, let's say 2 years ago, told me, "Oh, what would be the good use case for 5G?" I would never be right on that, because this is a case that we weren't expecting. And again, it's happening not only in one side, in my side of the globe. I see here in Latin America some 5G operators born as wholesale operator, but we're seeing this is in all over the globe. So it's a case that we should analyze. The 5G wholesale networks usually provide not only the G-Node Bs, not only the access terrestrial station, but also the AMF. Why so? Because of compatibility. So they handle the mobility of the subscribers while they are in their network. So again, this is a case I wasn't expecting, a shared core. So in order to allow their customers, which are national mobile operators, to homing into their network, they should allow this communication, signaling communication from their cores to AMF. So they have not only straight vulnerabilities that some attacker could tamper with their AMF directly, but someone attacking their customers could also reach out for their AMF and send some bad signaling to it. And by the time that they have integration and their customers have international roaming, it just takes the first subscriber using the wholesale operator access network for one attacker to be able to craft a message and coming from international links straight to their AMF. Okay, so this is about the borders we don't see when you plan the business, right? You just build it and you say, okay, so now let's look at what I have built and double check. What have you recommended for this use case? So first step, we have our product ACE on premises, inspecting their AMF constantly for signal security posture to see if anything can be abused if any change of configuration, I put a single AMF, but there are some AMFs available on that network, and they may be configured differently. They may be, let's say, using a different software release, etc. So this is about making sure that you have the right software in place. As a second step, we start monitoring this, and these steps are not, let's say, 1 year, 2 years. These are short-term steps, right? So we are performing. So what we could say about this should be monitoring for any malformed packets, any attacks, etc. And so we have visibility, and you can also do forensics. And if something happened, you can assure if this was intent of tampering of the network or not, because you have stored evidence of it. And the third step, you just filter it. You make sure that just the right message and the expected message, authorized one, comes into the AMF. So that's how you build for a resilience network, right? And then again, this is a scenario that the operator has just a single element of 5G core, and they already decided to implement intrusion detection, protection from start. But in daily maintenance and evolution of a full 5G network, maybe you could also rely on a lab environment, right? Rather than doing it all, let's say, on the heat of things, on the live network. So what we're seeing is that the requirements on a 5G lab, the gains are clear, right? So you're doing tests and you can do training, you can do cybersecurity drills at no risk. Security assessments are low risk, but I can never say they are zero risk because they are touching a live network. So when using a lab, you must ensure that you have real 5G coverage, because if you start virtualizing everything, then you're virtually secure because you never test the real deal. So you should be using real 5G terminals, have a small 5G coverage in place. You should have the 5G core enabled. The infrastructure must be as complete as possible. You must have this expertise to perform the tests, right? There's not the expertise on building the network. There are different, let's say, skills, and you should have the tools, right? So what we have, yes, we provide the lab, which comes with a set of network functions. It allows you to test the other functions into it, test for protocol vulnerability, attacks from the 5G mobiles, from the access network, and even to verify the vulnerabilities that are inherent to your architecture without risking anything on their network and without needing that CTO signature that must be done every time you do a single assessment on a single function, right? So again, this I didn't dare to define. So how do you onboard your network functions and new release today? So if you want to put some questions or some statements on the Q&A, I would appreciate so we can have a richer discussion in the end. Okay, so let's wrap up what you say, John.
Our approach is IDP, which is inspection, detection, and protection. So with the inspection approach, we provide the full visibility on your current security level. So you will have a full understanding of the potential risk of your network, your service, and your subscriber. And this is super important as many operators still think their network is pretty much secure and not vulnerable. So inspection result give them a big turnaround point. And with the detection approach, we provide continuous real-time monitoring on parameter. So it provides real-time detection and recommendation. So you can take immediate action and mitigations. And this is also important because you now have a full visibility of what's going on in your parameters. And when there is incident, you will know it immediately and you can investigate as quickly as possible because you have the data from our detection module, which is our TSG IDS. And when it comes to protections, we can completely secure your network by addressing both generic vulnerabilities like GSMA recommendation guidelines and threats that are affecting your network and your service and your subscriber. So I'd like to highlight that with our TSG NG firewall, which is a combination of detection and protection, these two modules are interactive with each other. It provides the correlation between threat detected and blocking event, which provide the most accurate and effective protections. So, okay, this is it from my side. Gustav, maybe you might want to add or elaborate here. Quick.
Oh, I can't add much to you, John. I just covered everything. But again, when we talk about inspection, detection, protection, those are the first three functions defined by NIST. So it's not an, let's say, such an innovative approach, but it's a known one and a proven one, right? And what I can add is that which functions to apply and where to start, it depends really on security posture, which is the security strategy of the customer and the risk appetite. Maybe if you have a 5G network that handles critical data, etc., maybe you're going further than that, right? You're going to the next functions of NIST, or you're having protection enforced not only at your network, but also for your let's say you put it on contract for your wholesale provider, for knowing the size of your network to norms, etc. That it's a lot of documents, it's a lot of information, and we could help you to find your path across it. And that would be that.
Okay, so this is it from our side. Thank you very much for listening all this. So now we'd like to have a Q&A session. So if you guys have any questions, any comments, please, now is the time.
Thank you all for joining. Thank you all for collaborating on the post as well. Those represents a lot for us, and in a matter of really knowing what is the view of the market. Sometimes we have some bias on our view, maybe we are missing something. So if you want to do any questions over it or some comments, just chat us. Thank you so much for participating.
Thank you very much.
Thank you. Thank you very much.
Okay, John, since there are no open questions, really appreciate everyone to coming.
Yep, thank you for joining. If you have any question, you can just send email to us, so we'll get back to you with the answer. So again, thanks very much for joining.
Thank you. Bye.
Bye. Cheers.